All right. So for these past 2 weeks, we've been talking about ratios, and now it's time to talk about something that is kind of the same, but a little bit different. So rates are a type of ratio that compare things that have different units. And so the first question we're going to answer are, what are some examples of different units? And if we were in class, we'd do a big brainstorm. Maybe I'd get you to raise your hand and call them out. Maybe we'd all write on the whiteboard. But I'm just going to give some to you as an example. So we have M for meters. We have km for kilometers. Whoa. We have liters. We have grams. We have kilograms. We have pounds. We can use imperial units. We probably won't do a lot of that. We have dollars. We have cents. We have units of time. We have seconds. We have minutes. We have hours. And these are all examples of different units that we might run into. And we see rates a lot in our daily lives, actually. One of them is speed limits. Right? A speed is like a rate. It's measured in kilometers per hour, which is a unit of distance per a unit of time. Here, I'll just do a little circle of that there. Here we have gas prices. They are in cents per liter. So 1 liter of gas would cost 135.9 cents. So cents per liter. And we have another one here. Here are some fresh salmon fillets, color added. I don't know what that means. But we can see here we have what's called a unit price, which is 999 cents or $9.99 per pound. So that would be $1 per weight of salmon. And so all of these ways are sort of how we would write rates. And so we're going to do some examples of just writing a rate down. So here's one. We're talking about light in science class right now, so this is pretty topical. Light travels 792,458 meters every second. Write this as a rate. And so we are just going to copy that number down. And then meters is M. And second, we very commonly use S. So we could write this like this. Or we could write meters per second, because that's what that means. And both of these are acceptable ways to write this. All right, here we have another example asking us the exact same thing. At Tim Hortons, a large coffee is approximately 563 milliliters and costs 199 cents or $1.99. Write this as a rate. So we're going to write this as dollars per milliliter, right? You could also write milliliters per dollar, but I think dollars per milliliter, if you're buying something, makes more sense, right? So we could write it like this. And it's $1.99 per 563 milliliters. And you might be asking, oh, Miss Miller, we didn't have a number in that first one, right? We didn't put the 1 in front of seconds. And that's true. If it's just 1, we usually don't put the 1 in. We just say per second. It's implied that there's only 1 second there. And so this would be a rate, or we could write this as how we would say it. $1.99 per 563 milliliters. And that's just how we would write those as a rate. Moving on. there's a special type of rate called a unit rate. And we call it a unit rate when the second number is 1. And so this, for example, is a unit rate. And we could write it as 50 kilometers per hour, right? We don't need to include that second number because it's 1, and that's how we know it's a unit rate. If we go back to the other page, and we scroll up here, you'll notice that the speed limit is written as a unit rate. It is 110 kilometers per 1 hour, so it is a unit rate. Similarly here, 50 kilometers per 1 hour is a unit rate. This one over here, however, is not a unit rate, right? Because we have 350 kilometers per 2 hours. And that is just not a unit rate. The second number is not 1, and therefore it is not a unit rate. And this distinction is important because we like unit rates. Unit rates are very helpful when comparing things. And we'll see this in an example here. The question is, what's a better deal? 12 hot dog buns for $2.20 or 10 hot dog buns for $1.80? You might be wondering, it's 40 cents. What's the big deal? Sure, whatever. You don't want to save 40 cents, but what if you needed to buy thousands of hot dog buns? That 40 cents per package difference could get pretty astronomical, right? Even if one is just a little bit better of a deal, if you're buying a lot of them, that could save you a lot of money. And so let's do this little example here. So we have 2 rates here. We have $2.20 per 12 buns. And then I'll use a different color for the other one. We have $1.80 per 10 buns. And what we do here to figure out the unit rate is we are going to divide by the second number. So the second number is 12, and I'm just going to make a little note here. Divide by the second number. And we're going to divide both numbers by that second number. So right here, we're going to do 2.20 divided by 12. Right? And we are going to grab a calculator and we are going to do that. So let me just grab my handy dandy calculator right here. You think, Miss Miller, why don't you have this written out ahead of time? I don't need an answer key. I'm confident. And this is going to end up being 0.18333 repeating. Let's just do 0.18. And then 12 divided by 12 is 1, which is what we want, right? We want that second number to be 1. And so then we can write our unit rate as 18 cents a bun, or $0.18 a bun. Because our original unit was dollars, our answer is still going to be in dollars because we haven't changed it. Okay. So now we need to do it for the other one. So we're going to divide by the second number. Uh, 1.8 divided by, I've made a mistake. Divided by 10, because our second number is 10. And that is going to give us, oh my goodness, I've made a bad example here. How interesting, if you know what's going on. Okay, and then 10 divided by 10 is equal to 1. And oh my goodness, they've turned out to be the same. So there isn't a better deal. In this case, it would just depend on if you wanted 12 hot dog buns or if you wanted 10. That's interesting. You might think, oh, but Miss Miller, the first one was 0.1833333, so it technically costs more per bun. And you'd be right. But I do believe our prices would round down in that case. So it really doesn't make a difference. Interesting. I didn't plan it that way. But hey, that works out. All right, here's another example. Suppose you completed a 100-meter dash in 14 seconds. What's your speed in meters per second? And another way to ask this question would be, what is the unit rate? So you went 100 meters. I hope you can't hear that phone ringing, because that is very annoying. You completed a 100-meter dash in 14 seconds. So you have 100 meter per 14 seconds. And we are going to make that second number 1. So what do? We divide by the second number. We do 100 divided by 14. And that is going to equal 7.14. And then we do 14 divided by 14, and that will always be 1. Our second number should always be 1 if we've done this correctly and we've divided by the second number. So that tells us that your speed is 7.14 meters per second. Pretty simple. You write out your rate, you divide by that second number, and then that will be your unit rate. Okay, and we have one more example here. So we talked earlier in this very video about how a large Tim Hortons coffee is $1.99 for 563 milliliters. An extra large coffee costs $2.19 and is 678 milliliters. Which size costs more per milliliter? All right? And this part here, which size costs more per milliliter, tells us that our rate should be in cost per milliliter. That's what we're looking at here. So let's write out our rate. The first one, the large coffee, is $1.99 per 563 milliliters. All right. We grab our second number and we divide by it. So $1.99 divided by 563. That's going to give us a really small decimal. It is 0.0035 what? Dollars per milliliter. Once again, a very small price per milliliter, but this lets us compare the two different sizes in a fair and equal way, right? We can't just say, oh, the extra large costs more, so the other one's a better deal. You get more coffee, and so it's up in the air. We have to do this calculation to figure out what's going on. All right, so let's do the extra large. $2.19 per 678 milliliters. All right. Find that second number and divide. Take out a handy dandy calculator. I am not expecting you to be able to do this by hand, so please use a calculator. 0.0032 dollars per milliliter. All right. So the large has a higher cost per milliliter, which means that the extra large, in this case, is a better deal. Does that make sense? Right? If one costs more per milliliter, then the one that costs less per milliliter is going to be the better deal because we want to spend less money. So we could write our answer in a sentence. The extra large coffee is a better deal. And I'll move down a little bit.